Okay, so I wanted to go over two of the questions from exam 5. This one said students were given different drug treatments before reviewing for their exams. Some were given memory drugs, some a placebo drug, and some no treatment at all. The exam scores are shown below for the 3 different groups. Using the Excel Nova output, answer the following questions. So we have our memory group, placebo, and treatment, and then you'll notice that we get our summary of our ANOVA Excel output and the rest of our summary right here. So starting off for question number 1, where we want to talk about the null and alternative hypothesis. So the null hypothesis, H sub 0, we have a couple of different ways we can write this. We can write it in sentence form, which would be that there is no difference in test scores for the 3 groups, for the treatment groups. Running out of room there, so kind of work that. Okay, so that's one option, is that there's absolutely no difference in the test scores. So that's one way we can write that in words. If you don't like writing it in words, we can also write the null hypothesis as mu1 is equal to mu2, which is equal to mu3. So basically the means of all 3 are equal to each other. So that's another option there. And our alternative hypothesis would be that there is a difference in test scores between one or more of the groups. Okay, so that would be our alternative hypothesis. And again, if we don't want to write it in words, we can do, again, the whole alternative with mathematical symbols. And this would be that mu1 is not equal to mu2, which is not equal to mu3. And what we would do on this alternative way of writing this is however many groups we would have would be the number of mu's. And then we just make sure that we're doing 1, 2, 3 here. So obviously if we had a 4th group, not equal to or equal to mu3, or mu4, excuse me. Okay, so the second question just asked you what the critical value was. And if you come back up here and look at your chart, you'll notice that this very last row, or excuse me, column says F critical. So that means that the answer for this one is this guy right here. So the answer for our F critical is 3.8859. Oops, nope, not 59. I've missed a number there. 5294. You can also go ahead and round that to 3.89. I accepted either one of those answers as an option there. So then the third question asks what the F statistic is, and you'll notice we have a column that says F, and it's given us a value right there. That is our F statistic. So in this case, our F is equal to 50.16007. And again, if you rounded that to 50.16, that was fine as well. Either one of those answers was correct. The next question is, should we reject or not reject the null hypothesis? Now, what I want you to remember here is if I'm thinking about my F statistic, my graph looks something like this. It's a little bit kind of off skewed for the ANOVA. And we have a critical value right here at 3.89. And what we're saying is anything that falls in this area would be to reject. Okay? And anything that falls this side would be to not reject. Well, our F statistic is 50.16. Well, that's definitely way out here. 50.16 is definitely bigger than my critical value here. So in this one, we would reject. Okay, again, as long as my critical is smaller than my F-stat, then we are going to reject. Okay, now we can also really quickly look at our p-value and notice that our p-value is incredibly small. Anytime you see this e to the 0.6, that just means that that decimal would move forward, or it would move to the left 6 spots. So you would have point with 5 zeros, 149, which is a very, very small number, definitely smaller than an alpha of 0.05. So we would also see that we could reject there. Now, as for what conclusions we can make, remember that my ANOVA is not telling me which of my treatment groups are different. All it's telling me is that there is a difference. So when we write our conclusion here, it's going to be something similar to there is significant evidence to conclude a difference exists between the treatment groups. Oops. Notice I didn't say that the drug worked or that the placebo worked or that the no treatment worked. I just said there's some difference. We don't know what it is. But we know that there's a difference between the treatment groups. In order for us to determine what treatment, which ones are significantly different, this is where we have to do this post hoc. And all that means is we have to perform a couple extra tests. We have to perform additional statistics to see which of the group is actually significantly different from each other. Because, is the placebo different from the no treatment? Is the no treatment different from the memory? Is the memory drug different from the placebo? And these are all kind of really important things to look at, especially when we're looking at a medication. Because if we look at and say, yes, the memory drug worked, it obviously worked. Look at the difference we've gotten here. But we don't look at the memory drug versus the placebo, then we're not going to see the whole picture. Because what if there's no difference between the memory drug and the placebo? So did the memory drug actually do anything to help, or was it just the thought that you were going to have this memory drug that was actually going to help you remember what you studied? So we really have to look at all the different situations when we're talking about ANOVA. Once we say yes, there is a there is a significant difference between the groups, then we have to go on a little bit further and actually figure out what those differences are. And if you go in further in psychology, eventually we'll talk more about that test in other classes on how to figure out which of the groups is different. Now, the second question is about a regression analysis. So it says Janice and Paul did a study on feelings of stress and life satisfaction. Participants completed a measure on how stressed they were feeling on a scale of 1 to 30, with 1 being no stress and 30 being very stressed, and a measure of how satisfied they felt with their lives on a measure of 1 to 10, with 1 being very unsatisfied and 10 being very satisfied. I want you to notice something. The scales are very opposite. So if I do a 1 on my stress test, that means I have no stress, which typically is usually a positive thing. Whereas if I do a 1 on my life satisfaction, I'm very unsatisfied with my life, which is typically a negative thing. So you can kind of see right there, just from the way the scales are measured, that most likely this is going to be a negative correlation, because the more stressed I am, the higher I go from 1 to 30, the assumption would be the lower my life satisfaction would be. So since I'm going that opposite direction, as my stress level goes up, my life satisfaction goes down. That usually is kind of a key to a negative correlation there. And it says the table below indicates that participants' scores using the data, the scatter plot, and the regression output answer the following questions. So there's our data, there's our scatter plot, and we can definitely see that downward motion that we're getting. The lower my stress score, the higher my life satisfaction. The higher my stress score, the lower the life satisfaction. It's fairly linear here. And then we've got our regression output, we've got our ANOVA output, our coefficients, and we're going to go through here. It says, using the scatter plot and regression output, write a brief interpretation of the correlation, including strength, direction, and explanation of effect. So this is kind of just basically what I was just talking about. So from looking at my scatter plot, the points are fairly lining up on a line. I know there are some differences here as far as distance from that line there. So it's not completely linear, which we don't expect it to be, but it is fairly linear. So I would say that this has a pretty strong correlation without even looking at what my R value is. Just looking at the graph itself, pretty strong correlation. I can come in here and look at my multiple R here, or my regression analysis, and I can see that it is a negative 95%. So we're looking at a 95% correlation, which is fairly high. I can also look here at my R squared and notice that the stress level is are covering about 91% of the variability in life satisfaction. So it's a very high R squared as well. So we can kind of say this is a pretty strong correlation between the life satisfaction and stress levels. So that's kind of what we would write here. It's a strong correlation. I'm not going to write this as a sentence because it'll just take forever to write it down. So we have a strong correlation. We know it's going to be negative. Okay, and that means that as my stress levels go up, then the life satisfaction goes down. And again, writing these as a sentence instead of what I'm doing here, just kind of summing it up for you. So that's really what we're looking for there, just strong correlation. It's a negative. If you want to tell me that our correlation is a negative 95%, we can talk about that as well. But just again, looking at that satisfaction level. Now the second one says we want to write the regression analysis line. And if you did the regression homework for the Excel assignment, you should know how to do this. One shouldn't have been too bad because you're just literally picking out values. Remember here, the intercept, this is going to be your B sub 0. And what I'm talking about is this guy right here. And then the stress score X here, this is going to be your B sub 1, this guy right here. So this is your slope. This is your y-intercept. Okay, so when we write our equation, it's going to be y equals 10.78. And if you use the whole number, that's perfectly fine. I just kind of rounded it to 2 decimal places. And now notice that my formula says plus, but right here in front of my my slope, it's negative. So when I write my formula, I am going to do minus 0.36x. And again, if you use the whole number that you see on the chart, that's perfectly fine. Or you can round it to 2 decimal places. Either one was fine as far as that goes. The biggest thing here is making sure that we do change that to a negative right there. I also had another, just kind of as a side note, I did have one other person do this one where they switched it around and they said y equals negative 0.36x plus 10.78, and that is completely correct as well. Either one of those answers is correct. If you modeled it after what I had here on the paper, then that was fine. But if you wanted to do it like we do in the actual math classes here, and you want to do the x first, that's perfectly fine as well. Either one of those answers is correct. So now we're going to come in here and we're going to figure out what a person's life satisfaction score should be if they score this, one of these two, on their stress levels. So this is their stress level score, and we're going to try to figure out what their life satisfaction score is. So basically, again, what we're going to do is plug those guys in into our equation for x. So for the 4, we're going to do y equals 10.78 minus 0.36 times 4. So then we're just going to do our math really quick on this. So 0.36 times 4 is going to give us 1.4. So this is 10.78 minus 1.44. So 10.78 minus 1.44. And we get a life satisfaction scale of 9.34, which makes sense, right? So this is, remember, my scale for stress was 1 was least stressed, 30 was the most stressed, or no stress, and then 30 was the most stressed. And my scale for my life satisfaction was 1 was very unsatisfied to 10, which was very satisfied. So it makes sense that somebody who scored a 4, which means there's not very much stress in their life, has a fairly high life satisfaction. Remember, the highest this answer can be is 10, because that's my life satisfaction scale from 1 to 10. So if I get anything bigger than 10, I know I've screwed up. All right, so let's do the next one. So the next one we're going to put in 13. So we're going to do 10.78 minus 0.36 times 13. So again, 0.036 times 13. That's going to be, oops, I messed that up, 0.36 times 13. I added an extra 0 I didn't need. This is going to be 10.78 minus 4.68. So when we do that, 10.78 minus 4.68, we end up getting 6.1. Okay, it's got about a medium level. 15 would be halfway between 1 and 30. You're at 13, so that's about halfway on your stress level, and 6 is about halfway, a little higher, since 13 is a little bit lower on your stress than half, and then life satisfaction a little bit higher, so makes sense again. And let's do 21, so 10.78 minus 0.36 times 21. And just as a note, remember 21 is a pretty high stress level, so I would expect my life satisfaction score to be pretty low. So we're going to do 0.36 times 21. So that's 10.78 minus 7.56. So doing that, 10.78 minus 7.56. And we get a life satisfaction score of 3.22. And again, if you did your regression analysis using the full numbers from the chart instead of just rounding them, your values here might be just a little bit different than what I have as far as like just the decimal portion of it here with the 3.4 or the 1 or the 6.22. And I did take that into account when I graded this particular answer. But you should get around about the same decimal representations that I've got here. Now, the last one says, can you say that being more stressed causes a lower level of satisfaction, life satisfaction? Here's the deal. This is the key word on this one, causes. I want you to understand that correlation is not causation. I cannot ever, anytime I run a correlation statistic, I can never say that one thing causes the other. Now, can I say they have a relationship? Yes. Can I say it appears that the higher your stress level is, the less you're satisfied with your life? Yes. But I cannot say that stress levels cause life dissatisfaction. There we go. So that is the biggest thing on this. I can say they are related. We can talk about how they're related and how there's a negative relationship and how it appears that the higher your stress level is, the less you're satisfied with life. All of those things are true, but I cannot say that there is a cause between these two things. And the biggest thing I can get you to remember this is there is a study between the amount of ice cream eaten per day or per month and the amount of homicides in the city. So obviously, the more ice cream we eat, the more homicides happen in the city. So we should stop eating ice cream. Okay, there is a strong positive correlation between the amount of ice cream sold in a city for a month and the amount of murders that to happen in that month. And so obviously ice cream is causing murders. So again, things can be correlated together, and then some really weird things can correlate together that have absolutely no causation on them at all. So that's one of the big things I need you to remember about regression analysis is regression and correlations do not mean causation. If you have any questions over this exam or any of the problems that you didn't understand, just email me, let me know, and I can go over any of those things with you.